Hi everybody, welcome to another SU2 developers meeting. As many of you know, we had a joint webinar the last 2 days with Pointwise, the meshing software, and the mostly introductory stuff, so how to SU2, how to meshes with Pointwise. The second day we talked about more advanced features, so if you wanted to start editing the code, where to go, or if you wanted to do 3D meshing in Pointwise. So does anybody have any comments about how the webinar went, or sort of other conclusions from it?
Yeah, I think that we have a great audience both days. The first day is important, is when most of the people are there. But I was very happy to check that even the second day, that it was more developer session, more advanced topic. We have more or less of attendees, and we were always 100 because between what we had. Online and physically at Stanford, so yeah. It was a great experience.
I want to agree that the second day I think was really important because we finally got a lot of material ready, pulled it all together, had a couple of presentations on it. So I think that hopefully you guys out there find that really useful as you get started developing the code. Get your hands dirty in the code.
In particular, if you have opportunity, check it out. Any environment to develop the code. I think that's very useful. The link is in the
And I'll add one more thing. We're asking great questions, and a lot of people that wanted to get into the nitty gritty of the code and kind of like, hey, where's this line number? How do I add this particular thing? So that's great. Please come to the forum, and we'll get to that in these meetings. But do you guys have anything you want to add? I'm talking too much.
No, it's just great. The amount of attendees and the amount of questions we have, so we'll try to use these meetings to keep answering some of your questions, the ones we didn't get to, and hopefully the videos we provided were helpful. So if you have some questions, we'll be editing those videos, and they'll be out within.
Yeah, we are post-processing videos as soon as possible. Yeah, it's not easy to post-processing. Provide something. We need to post-process and check that the quality of the sound is the right one.
Yeah.
So that's for us. We have started planning the next workshop in 1 year, so we need to look for a partner to organize the workshop. I don't know what this could be a interesting partner for another.
I have one idea. I really think we would like output and visualization folks. I think that would be a good place to go.
ParaView.
Yeah.
Maybe we need to think about that and see, because there are a lot of people that are interested. Well, most of the community use ParaView,
TechPlot,
Inside, yeah. So maybe we can contact a visualizer company.
ParaView is open source.
ParaView is open source, so it's going to be a good match.
Yeah, kitware,
and we are even thinking of creating a GUI environment. So maybe ParaView. So if somebody from ParaView is looking at that, please contact us.
Do we really need a GUI?
I don't.
That's a good point, because in some sense everybody runs this kind of software in a supercomputer that they really don't have the opportunity.
Plus, like, the difference between Pointwise and SU2 is that sort of the feedback on what you're doing is so much faster. You have something like SU2, yeah, the flow solver is solving, but it's not like you're going to be modifying lots of things all the time. So
yeah, ease of use and control, and Travis even talked about fine-tune control. I mean, it's okay. It's not as easy to work on a command line, but you can see everything. You can go in, you can change everything, you can change the code.
Well, plus, like, a GUI is a ton of work.
To make it.
I mean, dependencies when we ship it.
And at least my experience with stuff, like, it's not easy. It's not easy to install.
Well,
at least my minimal experience. So
nice package in Python, but it adds dependencies. Maybe we could ship an executable that doesn't change.
Of what?
An executable, just
something that's precompiled.
For the GUI?
Executable for the GUI.
Sure.
It's a good opportunity to ask what folks out there want to see, and if you have a lot of feedback, maybe you guys really want to go. Let us know what you think. Maybe we can.
Maybe write a GUI.
Or wants to work on a GUI. Let us know.
That's the more.
We'd love to hear from you.
Crucial thing, in my opinion.
Yeah.
Someone wants to build it. Maybe I'll use it.
They will come.
Yeah.
Okay, I think we need to move on, but we really need to thank the Pointwise.
Yeah, definitely.
great job in here.
And for all the folks who traveled here locally and joined us online, I mean, it's great to have you guys.
And even if you're only interested in CFD, care about meshing, like you should still look at the pointwise stuff because they have a really impressive tool set. I was very impressed at how easy it was to construct and change things and like,
how good this pointwise. It
Yeah.
was very well done. Doesn't crash. Everything was smooth. So
Come on, we don't crash either.
Well, we don't.
Our code never breaks.
and like the response on his computer was really nice.
everything was real time. Yeah.
Yeah, it was very nice.
Yeah, and even if you've used pointwise a bit, how I have here, I still learned a ton of tricks. So those videos.
The videos, the videos are gonna be in YouTube, I think. So they will be uploaded. Wait a moment.
Okay, yeah, let's get into some questions, see how many we get to before we run out of time. But we want to do the same thing we were doing last week and questions off the form. I'll read them and kind of discuss them and give you some answers, and hopefully we can put those up on the forum like we did last time. Links to the spots in the video where we discuss these and you know keep having the interaction this way. I think it's very positive. So, okay, let's start with the first one. We have a question from Jeffrey. It says, "Hello, developer team. Two-part question regarding SU2. I've been working with SU2 for a few months now to complete my master's thesis. R has been focusing on validating the software for my purposes, and now it is time for the next step, which is generating an aerodynamic database of a hypersonic vehicle, I should say. So the first question of the two-part, can the convergence criteria be applied to the energy equation rather than the density equation, essentially? The reason for this is they're also interested in decent convergence of heat fluxes and temperatures, which would be related to the energy equation. So, do you guys have any thoughts about this?
Yeah, I think this is a great opportunity to show the flexibility of SU2. In principle, you can specify the convergence that or any parameter that you can choose in the solver. For example, I'm gonna make a demonstration. Please. Okay, sound is working perfect. So, if you go to the code, for example, in this subroutine, that is a very useful subroutine. This is in integration times CPP. Here is where we define the main loop for the multi-grid cycle or the single grid cycle. And if you go down at the end of scroll down at the end of the subroutine, you will see this non-dimensional parameter. So in these non-dimensional parameters where you compute forces, you compute residuals, and so on. But you also, in these subroutines where you compute what we call monitor. A monitor is the parameter, the variable that you are going to use in order to evaluate the convergence of your simulation problem. So here in this subroutine, you evaluate monitor. A monitor, for example, by default probably is the density or lift or drag or the coefficient you have chosen. And then if you go to convergence, you will apply a particular criteria to decide if you have converged or not. So the key here is to choose or to feed to this subroutine the right value of the monitor. So if you want to change this, by default you're using drag, but you want to use pitching moment, the only thing that you need to do is to provide another value for this monitor, and this subroutine will be in charge of checking that residual is satisfied or the Cauchy criteria is working or so on. So yeah, this is what I want to say about this. Yeah, well, I don't know if you have any, do you want to add something?
Could add something, so
change to the camera.
Yeah, so thanks for Francisco for showing us where that is in the code. So yeah, you need to change monitor. So I would encourage Jeffrey to go and just go ahead and change that to the quantity you need. So like change it to RhoE, and you could even hard code it in the code, and that's a way to start. So if you're going to start somewhere modifying the code, that's the best way, and then once you get that, then you can look into like, oh, maybe now I just want to specify directly in the config instead. I can say I want to monitor the energy or the heat flux for that. And for that config option, and we went through that in the workshop yesterday or 2 days ago. Yesterday. Okay.
Yeah.
So look forward to those videos because then when they come. But yeah, I think the easiest way I got started is just kind of make hard code the changes yourself, and then once you might want to make it a little look into expanding, like making a config option or something like that.
Yeah, I remember Brendan yesterday said that something that is very important. If you want to implement a change in SU2, tell us before starting the big implementation. Tell us about the change that you want to implement, because this is something that we can.
Yeah, although when Francisco says that, he mostly means if you want to make a change that then gets ported back to the main solver. If you change for yourself, then
that's perfect.
You can just do it.
But if this is something that you really would like to see in the master repository of SU2 and in the typical release that we made, please chat with us, and that's going to be useful. I don't know if you want to add something.
Anybody else? No? Okay, let's keep moving then. We have a few more questions. So this is the second part of the question. Is there a nifty and useful way to create an aerodynamic database, so force coefficients, moments, etc., for various Mach numbers and angles of attack? I have a set of Mach numbers, and I'd like to and heat fluxes, etc. So, I can complete config files myself and submit them to a cluster, but is there an easy way to do this? So, Trent, I think something to say about this one.
Yeah, this is a great thing to attack with the Python script. There's an example you can start with in the SU2_pi directory called compute drag polar. .pi. Give that a look. It'll show you how to script SU² and run multiple configurations. In fact, it does exactly angle attack. You have a little bit of a special case here in that you want to be able to run multiple jobs at once, I think, on a cluster. And in order to get into a little bit more advanced scripting, I just talked about that at the Pointwise webinar 2 days ago, and we have a video for that. The slides that go with that might be a great thing for you to take a look at. That's available on our documentation repo. If you go to SU2 code, the GitHub organization, find our documentation repo, the third workshop folder. In there is a PowerPoint, or I think a PDF of SU2 surrogate optimization. And that'll be a great place for you to start. Yeah. There's some good example code as well that's available, and that's in that presentation.
The other thing to just be wary of is that sort of if you want to run on a cluster, the details are going to depend on the cluster. The cluster has its resource management system, so it's not really straightforward, and it can be straightforward or not depending on what you have, but it's really hard to sort of answer that in the general way because it very much depends.
Yeah. Although we do have ways of changing. Let's say you need to call MPI run, or you need to call MPI exec, or srun for slurm. We can point you where in the Python scripts we can modify that for your particular cluster. So.
Even things like srun or MPI run, like if you're on a slurm-based cluster, for example, like you kind of have to need to talk to each other, and if your goal is to run a long list of cases or something, you kind of have to I'm going to use the word fight with slurm a little bit and trying to figure out how it schedules, because I've had a whole bunch with it trying to schedule and things like that, so it's super straightforward.
That's a great question and a good example of how to use the Python scripting language to go at.
Yeah, just to finalize the question, I think that SU2 comes with a great Python interface that we really would like to see people using it and modifying that and Python interface, because we have a lot of questions about the C++ code, but the Python is as important as the C++ code because we want to automatize some. So take a look at the Python and ask us if you have any questions.
Yeah, so lastly, I a shout out. Jeffrey says, so keep an eye out for the meeting. So hopefully you get to see the answer the questions. Okay, the next one's from Nilesh. The question is, SU2 a few months ago and liked it a lot. I tried my hand trying to go through the code. It's a great development effort by SU2. I hope I would be able to contribute something to it. So that's great. Thanks for the. I was thinking for a scramjet inlet optimization, but as I understand the turbulence model is a coupled way, I would like to have a solver with a fully coupled system where the turbulence equations are included with the Navier-Stokes equations. A little bit of trouble understanding the code due to the lack of mathematical about how we're computing different terms. So I guess it's kind of a here. can we kind of help understand the theory a little bit more about what's behind SU2? And it seems like there's also some interest in having a fully coupled approach. So maybe Annika or Heather, you guys want to talk a little bit about some of these things?
Let me start. I'm off screen.
Yeah.
But Nilesh, I name on the webinar, so I know that you were watching. And so I hope to address some of your questions. We will be putting up a little bit about what the theory is behind SU2. And so I hope that was helpful. I'm assuming that this question was posted before. So if you want to say add into that.
So to the optimization of scramjet inlets, that's a task that I'm also attempting to do, and I would say my advice on that is to read up on work that's been done before on that. There's if you read it in a paper I have on our website. Francisco is also an author on.
Yeah, I think we.
But meshing is very important, especially for the viscous cases.
Related with that point, I think we need to upload all the publications that we have about or related with it to the web. Very useful. And apart from that, probably we need to create a list of the useful that we have used to develop the code, because we know all that work and to share with the rest of the people. So.
There are a lot of classic review papers I'm thinking of right now, and a couple of very good texts, especially, I'll mention two, my favorite. The Bible, as far as I'm concerned, is Charles Hirsch's book on CFD. The other one that's very, very good is a book by Blazik. It has methods in there as well, and that we use in SU2, so it's a good place to go look at the code.
And our own articles are very
and
good.
They're much, they're fantastic.
They're fantastic.
Look at my thesis too. If you want to read a
really good book about.
No, there are a lot of good references in there, so
good,
I could post that. I should post that.
So we will create at least with our articles, and people will be able to download.
So how about the turbulence part of the question?
Oh, that's very good. You want to say something about the turbulent part? Is this segregated? Maybe.
Sure. Actually, I'm going to use the screen, so. What's the fastest way to a web browser? Firefox?
I don't think Firefox. It's Safari. Yeah.
Okay, so the location of this is going to move, so if you're watching this video after the fact, the link might have moved, but it'll just go. It'll go to the documentation. But I just wanted to pull up this chart right here. So when you're talking about using a fully coupled solver, the chart here is showing what happens when the Euler equations or the Navier-Stokes equations alone are solved. And so through these space and time integration routines, these methods that are inside the solver class are called. And if you were solving a turbulent system as well, this C integration routine would first call the C solver routines for the mean flow, and then subsequently, because we're using a segregated approach, call a similar C solver routine for the turbulence equations. So to do the kind of thing that you're wanting to do, what you'll need to do is write a new C solver class, a single giant one, that has the equations for the mean flow and the turbulence together. And so this hasn't been done yet, but it's certainly something that the enough to allow for. So that's all I say there.
And we have discussed how to solve fully coupled problem, because it's something that we know that is in there. So if you want to say just one minute.
Yeah, we're thinking about different ways of leaving the classes and kind of the abstractions the same way they are now, but moving where the centers are, so that you have two separate storing heads and Jacobians, but under the hood they're actually storing it all in one big system that you solve. So we're starting to talk a little bit about how to do that, and
we are aware of that problem. We'll solve that.
Downside of solving them in a decoupled way?
It depends a lot on the equation that you want. So there are some equations that they have a weak link, and that's fine. You can solve those in a segregated way, but there are others like combustion and you need to solve everything together in a fully coupled system. So
because they're think of off diagonal terms that are going to interprogram. So okay, let's keep.
Decoupled, it's sparser, so it might be easier to split at the same time.
Yeah, you got to worry about how often you're iterating. So sometimes, sometimes people play games where they do multiple steps of the mean flow, steps of turbulence, or the number of steps you take before you couple back and forth. So sometimes you have to play games with that. Whereas fully coupled, you just drive it like you would the mean flow. Any other thoughts on that?
I guess, are we still referring to RANs and Navier-Stokes separately within the code? That there might be some confusion there.
Yeah.
If he's looking at the Navier-Stokes code,
You're right. Maybe we need to find a better word for that because it's a little bit confusing. Yeah, there's something that we need to think about because now we specify Navier-Stokes, but then you add the turbulence model. But in practice, as you said, you are not solving Navier-Stokes; you are solving average Navier-Stokes.
Yeah.
So it's something that we probably need to.
There are some.
In fact, you had this. We were going back and forth a little bit.
Yeah, I mean there are some naming inconsistencies between the config file and the internals to the code, and the reason why is because it's pretty easy to have a nice name for the config file, but when you want to change the code to have that new name, it's lots and lots and lots of lines of code. So we've made some effort to try to make the config files nice, but sometimes it's a little fruity when you go to look in the code. It's really different.
Let's keep moving. We have a question from Chris. I recently got SU2 installed and running on my PC, Windows 7. Very nice. I also have an iMac. It's a little bit slower, less memory, etc. After running some cases, I wanted to create my own airfoil. All right, that's great. So I started looking around for grid generators, if SU2 has its own or if folks rely on commercial packages. Looking for an open tool as a student, so something free or low cost. I guess the question is, does SU2 have a tool, or can we point you in the right direction? Yeah, I'll start this one off. I think there are a number of things I wanted to relay. So first, we do not have a full-blown mesh generation tool. We have a history here of pointwise, as you may have noticed after the workshop yesterday. So we typically use pointwise around here, and you can export your meshes straight to SU2 format. But not only can you export format, but you could also write your meshes into CGNS format. And any mesh generation tool out there that can write CGNS can be read in SU2. So that's anything that can write out a mesh in CGNS format, you can use in SU2. Now, I should also say there are a few other tools that the open source community has worked on. So you'll find a bunch of converters from things like OpenFOAM to SU2, Fluent format to SU2. They're all over the place, and a lot of them are on the forum. So maybe we need to do a better job of in one place. We've talked about this a bunch, but
there are open source mesh I can point you to. One is Gmesh, GMSH, which actually has an format in their later version.
Yeah, that's right.
And then Salome is something that I've used a lot that ends up working pretty well, especially for 3D meshes. And there's a Python script that can write an SU2 format on the forum if you dig for it.
There was another one called La Losterna, or
yeah,
was.
Yeah.
I'm not sure it was open source or proprietary.
Yeah, I guess the point is, if you check out the forum and we do some searches, maybe we can put a link, about this. But there are a bunch of tools out there. The last thing I did want to say is, if you're interested in airfoils alone, we have the SU2 tool, which is basically built exactly for this reason. So not only is it going to run the calculation for you, but by making one line change in the code, you can have it export a mesh. In SU2 EDU is you provide airfoil coordinates, and then it does everything for you. It takes a mesh that we already have for the NACA 0012, given a Reynolds number and some of the other conditions, and it's going to deform that mesh into the shape of the airfoil that you've requested with the right, etc. If you're running RANs. So if you make a change to that code, we can use that mesh, and you can use it as much as you'd like, or for other calculations or other things. So we can point you to how to do that. It's just within EDU. I would show you have EDU up, but we'll post where you can put that line on your reply. I think it's very easy to do.
Maybe an airfoil mesh generator called Dileando that is very good, very nice quality meshes, mainly for Euler, but they include now some kind of capability to to generate viscous meshes. So take a look at that. Tilon is a very good solver.
Yeah, great. Great. Okay, last one. This is from Paul. It says, downloaded the binary version of SU2 to my Mac. The folder downloaded was called bin. I've gone through all the folders and files, but cannot seem to find what I need to do to is there a README anywhere to get started? I am as green as onions on this subject, but would love to learn. So if anyone has the time, could you please? Thanks. So
Yeah.
So
this is kind of a more general computer question, but kind of the way it works is that we create SU squared by writing what's called, so it's lines of code in C++. That then what happens is there's a program called a compiler, and what the compiler does is it translates kind of the C++ lines of code into something that your computer can run. So it's basically a long list of numbers. It basically says the CPU should do instruction 1, and now you should do instruction 17, and that's a long list. And that long list is called the binary file. And so you can't really open the binary file in any GUI or anything like that. Piece of code that can run, and the way we interface with that binary file is through the config file. Open the config file, but what you can do is you can tell the binary to run with a given config file. That's kind of how you interface with it.
Yeah, so you interface from the command line, something like su2_cfd.exe.
Yeah.
Probably.
So.
And so you're gonna go to a command line in Windows and be in the folder with your config file and do su2.exe with your config file.
Yeah, and same thing on the Mac. A terminal application built in. Just search for it in your spot up and executable, and then the name of your config file.
In fact, I think in the latest release, the 3.2.2, inside the Vim folder, we also include the quick start tutorial. So if you want something to run, just copy that folder and compress that folder. And if you go to the quick start tutorial, you will have a mesh and a config file. And as always we said, you have a nice collection of tutorials from the very basic to more advanced topics. So just take a look at the documentation that we have, and if you have any particular question, I think this is the kind of question that the forum by itself is able to replay and answer.
Yeah. A quick extra note that
It's a Mac.
Doesn't matter. We can slash
Oh
it.
yeah,
Oh,
no,
okay.
but more.
But yeah.
I was here.
No, we had somebody running on Windows 7. It's fantastic.
alright, yeah.
But yeah.
Go
Well,
ahead.
actually, for both Windows and anybody else, is you're going to have to environment variables
Oh yeah, that's important.
to make sure that the executable can be found from wherever in your computer.
Yeah,
And-
or you can call it from wherever the executable
Yeah,
is.
that's it.
But if you are going to use the Python script, you must be more careful. I'm not completely sure, but the Python
You
Yeah.
just set the
Needs
SU2 run.
send
Yeah.
it to run. Okay, yeah.
And your Python.
That's all described on our installation pages.
And we went tutorial on Monday.
Yeah.
Yeah.
So
Which will hopefully be up at
That
some
should be
point,
available.
maybe, depending.
We'll have those videos up.
Yeah.
We'll get them.
Okay.
All right, I think that's all we have for questions. So, any other thoughts, guys?
To remind the people that if they have more questions, please, we have this online forum as the best place for question. We will take a look every week and we will replay as best as we can.
Yeah, and we're still working on the. Please give us feedback if you like the way this is working or running, or topics or different ways. Please just drop us a line on the forum about that too.
Thank you. Bye bye.
All right, thanks.